Okay, forgive me, I'm sick today. I sound terrible, but let's just go with what I can do for you. Okay, in parallelogram DEFG, DH, which is right here, is x plus 2, and HF right here is 2y. GH is 4x minus 3, and HE is 5y plus 1. Find the values of x and y. We know that in a parallelogram the diagonals bisect each other. So we can take this portion, dh, which is x plus 2, and set it equal to this portion hf, which is 2y. So we get an equation then, x plus 2 equals 2y. Notice this is an equation in two variables. We're not going to be able to solve that on its own. But we also know that gh, 4x minus 3, is equal to he, 5y plus 1, because they're bisected. So that means they're equal parts. Now, how do we do this? Well, we can do substitution, where if we can take one equation and isolate a variable, then we can replace the variable in the other equation with the expression that it's equal to. So what I'm going to do over here on the left, since we already have just an x, all we have to do is subtract 2 from both sides, and then it'll just say x equals, and that's what we want. So I'm going to say minus 2, x equals 2y minus 2. Okay, now we have an expression that we know x is equivalent to, and so in this equation in blue, we can say 4 parentheses, and what is x equal to? It's equal to 2y minus 2 minus 3 equals 5y plus 1. And then what you see here is now an equation with only one variable now. It used to have two, x and y. Now it's just got y because we replaced x with the equivalent expression. So we can then simplify it out by distributing here, this times this, and this times this, and we get 8y minus 8 minus 3 equals 5y plus 1. Okay? Combining like terms, we get 8y minus 11 equals 5y plus 1. And I'm going to subtract 5y. And we get 3y minus 11 equals 1. Let's add that 11 on to move the constants to the right-hand side, and we get 3y equals 12. Dividing by 3, y equals 4. And hopefully you can see the value in showing all your work and being consistent, because you can really clearly get to the answer without confusion. So we know that y equals 4. Now, I could replace y with 4 in the other equation, but it's really important for you to start with the original equation. We modified this, and if we messed up, then our answer might work in this one, which may be incorrect, but it wouldn't work in the original one. So we're going to start back with the original, just draw a line here, and say, okay, then x plus 2 equals 2y, and x plus 2 equals 2 times whatever y is equal to, and what's y equal to? 4, we found. Okay? So we get x plus 2 equals 8, and subtracting 2 from both sides, we get x equals 6. Okay, so we're looking for an answer where it says x is 6 and y is 4, and that is D. We're done. The trick here is you set segments that are equal to each other, those expressions that show their measure equal to each other. And since we have two equations and two variables, we can't solve this on its own. We have to use systems of equations, and in this case we use substitution.